Ladies and gentlemen, a very, very big welcome to Lecture 3. We are going to be talking about very, very important topics today because we are going to be officially starting all the calculations that are going to go and help you to be able to get a good outcome if you basically if you're basically going to go and participate into all the exercises I'm going to go and give you. There are exercises that I go and cover week after week. So if you don't actually learn what I'm doing in the first week, you're going to come to the next week and you won't be able to do the calculation next week because you haven't really learned the foundation. So what I'm teaching now is going to be all of these foundational things, one week after the other. And it's very, very important to be able to learn the foundational materials that are going to go and increase your knowledge on a weekly basis. So let's start talking about the first chapter today, chapter 5, which is about, we're going to need to go and estimate, project time and costing. To be able to go and deliver a project successfully, a project needs to be delivered within what? To have a successful project, a project needs to be delivered within what?
Certain time frame.
Within time frame. And what else?
Deadline.
Within time frame. And what else? Within time. Within what else?
Budget.
Budget. What else? So within time, within cost, and within what? And within the actual specification. Without actually delivering these three things, you won't be able to go and really reach the right outcome. So it's about thinking about all of these three components within time, within cost, within specifications. And at the same time, it's about thinking about delivering things within the quality that is going to go and really be accepted. If we start meeting the quality that the client really wants, we're not going to get the right outcome. And that's why we need to go and explain the subjects for you one by one. We're going to go and talk about estimating the time that are going to go and basically take to go and deliver a project. And accordingly, we're going to go and have to go and deliver the costing that is going to actually be related. So today we're going to build up on all of these things we've done in the first, weeks: introduction, strategy, organization, define a project. We're going to start talking about estimating the project, and we're going to talk about building the project networks. Now, this project network is going to start giving you the foundation for other things that you need to go and do. So make sure you're paying a lot of attention and participating in every single exercise I'm going to be giving you today. What are the learning objectives? We're going to go and understand estimating project times and costs, which are the foundation for project planning and controlling the project. If you want to get things delivered within time and within cost, well, you need to have a plan to compare things according to the plan. Let's compare what I was supposed to go and complete versus what I've actually completed. That's when we go the comparison, we're going to be able to get an understanding of the outcomes. Describing the guidelines. How do we estimate time? How do we estimate costs? How do we estimate resources? Describe the methods and uses of top-down estimating approach and bottom-up estimating approach. Two different ways for us to be able to make all of our estimation. And we're going to go and have to go and distinguish the different kinds of costs associated with the project. If we're not actually understand the various costing, we won't be able to really go and manage them. And when I say about the various costing, it could be niche machine, it could be people, it could be admin, it could be project management. It could be so many various costs associated with a project that we need to go and know, and we need to be able to go and really manage. Now, when I talk about estimating, we need to bear in mind that we're not going to always know how much something is going to cost us. We're not going to go and know something with, if you want, accuracy that is really required. So estimation is really, we're trying to forecast. We're trying to think, okay, based on some sort of planning, or sometimes without planning, sometimes based on our expertise, based on that, how do we actually go and make an estimation of the actual cost of completing the actual project? So the process of forecasting or approximating, not simply the cost, but also the time required to complete the project. Because with a certain time comes a certain cost. If you're going to go and complete something within a week, it's going to cost you one thing. If you're going to complete it in 6 weeks, it probably will cost you more, because we're talking about a longer project and potentially longer work to go and get the job done. So we need to try to go and create some sort of an estimate. And it's really about a task of balancing expectations of stakeholders and a need for us to be able to go and create control while the project is being implemented. You know, if we're not going to go and have expectation versus control. Expectation, I'm planning that something is going to go and cost me $1 million in the first month. Then we're going to go and have control because we have to go and make the comparison between our estimation and how much something is actually costing us in reality. So we need to make that real-time comparison to be able to see how much is actually going to go and cost me. So task of balancing expectations of stakeholders and need to control, you know, for control while the project is actually being implemented. So when I talk about estimates, I talk about various types of estimates. I talk about, you know, top-down estimates, and I also talk about bottom-down estimates. So these are different. These are not the same. Top-down estimate is where someone up there, they did not plan, they did not get the details. They're trying to give you an estimation of how much something is going to go and cost. For example, someone who built a house in front of me and who's building another house exactly next to it, they will be able to go and say, well, the first house cost me $1 million, the next house is going to cost me $1 million. That becomes the estimate. You know, this is an analogy where we kind of have something to go and compare to. If I've done a software and I'm making a very similar software, I might use my first software estimate to be able to be the second software estimate. So that's a sort of analogy I go and use. Group consensus or mathematical relationships. So we start making some calculations. Bottom-up estimate, on the other hand, is we kind of go and create a detailed sort of creation of what is known as a work breakdown structure. And when I talk about a work breakdown structure, I talk about all of these understanding, if you want, all of these understanding of the various tasks and subtasks that are associated with getting something to go and be completed. And by making that understanding and making that planning of all of these tasks and subtasks that are going to be required, I'll be able to go and estimate how much each task and subtask is going to go and take and how much it's going to go and cost. And as a result of that, what I'm able to go and do, I'll be able to go and try to create an estimate according to the use of that information that I've already created in the first instance. So you try to kind of rely on, again, some sort of planning to be able to go and really get the right information. Now, ladies and gentlemen, there are so many factors that might actually go and influence the quality of the estimates we are going to be actually getting. But before I do that, I want to go and just discuss something very quickly. I'm just going to pause my record. Now, ladies and gentlemen, there are many, many factors influencing the quality of our estimates. If I tell you, let me go and plan for the next 2 hours, it's going to be very easy for me to go and estimate. Then in comparison, tell you, let me go and actually estimate for the next, 5 weeks or 10 weeks or even 2 years of a project. It's going to be much more harder when we're going to go and start planning for much longer term in the future. The same thing is when we're talking about the duration. The longer the duration is going to be different. So the planning horizon could be in a week, could be months, could be 3 months, could be 6 months. The duration of the project is basically how long it's going to go and take. The longer the project is going to go and take, the more it's going to go and start becoming harder to go and estimate. The sort of people you're going to go and have. Some people might be an expert into a particular field, and because of this, they can actually go and give you so good of an estimate. In other hands, some people might not have the skills and knowledge that is required to be able to go and make a good estimation. And because of this, they're not going to be able to go and give you quality estimates that are going to go and be very, very good for us to be able to go and rely upon. The project structure in the organization. When I talk about, for example, a functional structure that we spoke about last week, it's much more different than me going and saying we are going to be relying on a project structure where we know people are fully dedicated on delivering a particular project. And because they are fully dedicated on delivering a project, they are going to have a much better chance and much better focus and much better knowledge on to get me an estimate that is more appropriate, because all their focus is on is on basically working on a particular project and ensuring it is going to be delivered. This is in contrast to other ways for us to be able to go and make an estimation. For example, if I say I am going to be estimating, and that estimation is more by relying on functional department to be able to go and do the job, the estimation is going to be different. And the reason why it's going to go and be different, because when I'm talking about people who work in a functional department, they are actually doing my project, but they're not really mainly focused on delivering my project. That's just simply one of the things they are going to be working on. So my estimation, again, is not going to be of the exactly same quality. Padding an estimate is one very, very big problem in project management. And the reason why is because what people try to do, they try to go and add an extra estimation so that if the project goes or a task goes and run for longer, they don't go and actually get blamed because a particular thing is actually taking longer than expected. Now, this is what we call in terms of the planning or the padding of estimation. People want to go and add extra time to each activity. Organizational culture might again be, effect of your estimation, such as, when the culture goes and start penalizing people because their estimate is not correct. And as a result, everybody starts being, very careful and very scared of getting any estimation that is going to be wrong. And there are other non-project factors. For example, there might be political power that might go and actually be existing in a project environment. And that political power might be something that, people might want to go, they might actually go and be scared about going and getting that information. So we need to go and think about that sort of things we need to go and really bear in mind. Now, continuing from here, now, ladies and gentlemen, what is the best way for us to be able to be making an estimation? The best way for us to be able to go and estimate is to follow the process, that is here. So what do we do? What sort of things we need to go and bear in mind? If you want to get an estimate that is correct, the best way for you to be able to get the correct estimation is for you to be able to go and ensure you are going to have people who know about estimation. I'm not going to go and get someone who works in gardening and tell them, can you go and estimate for me how much it's going to go and cost me to build a house? Because they simply don't have the expertise that is required to be able to go and give me the estimation. The best way to get the estimate is to get several people to make the estimate instead of relying on one person who might not have the best knowledge. The best way to go and make an estimation is to be able to go and base estimation on a normal condition, on an efficient way of working, on normal level of resources, such as someone going to be working for 8 hours a day as normal, which is what everybody will be able to go and do and sustain for an extended period of time. Use consistent time units. If it's hour, use hour. If it's minute, use minutes. If it's days, use days. Make sure you have that consistency when you're trying to make your estimation. Treat each task as independent. So if there's, let's say, a task of building in the room, but there's also another task of building the foundation, don't relate foundation to building the room. Estimate building the room by itself and estimate foundation by itself. Don't interlink and put a summary in terms of the estimation of two of those tasks together. Don't make for contingencies. In other words, don't say, the task is going to take me 1 day, but I'm going to estimate 1.5 days because I want to try to save myself or protect myself. And finally, make sure there's a good risk assessment to avoid any surprises that could go and influence how long the project is going to be taking. This could happen a lot of time, and that's something we definitely will need to go and really manage. So how do we estimate? I recommend doing the following. Get a top-down estimate, which is a high-level estimate of how much people recommend and believe something is going to go and cost. Then develop a work breakdown structure and an organizational work breakdown structure, which really talk about every task that needs to go and be completed. And organizational breakdown structure, more think about who from each department is going to go and conduct the job. Make a bottom-up estimate. So after you estimate you look at every single activity that you believe is going to be needed for a project to be completed. What you will need to do is you would need to go and estimate each of those various tasks that you thought and you plan that is needed to go and get the job done. Finally, by having all of these various tasks that you could thought about that needs to be done for the job to be completed, you will basically estimate the time each task will need. And as a result, the budget that it's need. If a task needs a week, it's different than a task that needs a day. So your budget is going to be different. It also would be different based on which resource you are using. Some resources would be very costly. Other resources won't be as costly as a result. Finally, what do? We go and actually reconcile all of those differences between the high level estimation and a detailed estimation that we got by getting all of these planning and considering all of these tasks that are going to be needed for the job to go and be completed. So this is a few of the things we need to go and really make sure you are actually bearing in mind. Now we need to think about the top-down approaches for estimating project net time and costs and the bottom-up approaches. The top-down approach, one of the approaches is called a consensus method. Now the way that a consensus method really goes and works is you go and get many people going in on a high level, believing and agreeing together that something is going to cost a particular amount of time. For example, we might get 2 builders and they might agree together that this house is going to cost $1 million for them to go and actually build. That's what we call a consensus method. A ratio method is another approach. For example, if I say every line of code is going to cost me, what's the word? If I say every line of code is going to go and actually cost me a $10,000 to go and be completed. And if I say I'm going to be writing 10 lines of code, then I know there's 10 lines of code because every line will cost me $10,000. 10 lines of code are going to cost me $100,000 for me to go and complete. So you go and get a ratio. You say, okay, this house is 500 square meters. Every square meters is going to cost me $100. Again, there's 500 square meters. That's mean this house is going to cost me $50,000 because every square meter is going to cost me $10 as an example. This is what we call the ratio method. The apportion method, and you're going to basically have exercises relating to these in a minute. The apportion method is something that is related to the ratio method. I'll give you a very easy to follow example. You go and say, I'm building a house. And they tell you, okay, this house is 4 levels. You say, okay, for the house, we are estimating that it's going to cost you $1 million. But we know that this house is 4 levels. And we know that every level is going to cost you $1/4 of the $1 million. So we know the first level is going to cost you $250. The second level is going to cost you $250. The third level, the fourth level, they are going to cost you $250. So what you've done, you did apportion that ratio, which is that $1 million for the whole house. You apportion it into smaller sort of ways. You apportion it into smaller calculation. You say, all right, we now need to go and actually think about it differently in terms of every portion of the house being completed. It's like I go and say, this software is 10 modules, which is going to cost me $1 million, which means every module, if I gonna go and apportion it, if it's the same equal size, every module is going to cost me, let's say, $100,000 because all 10 will cost me $1 million. So that's what we call an apportion method of making the estimation. A function point method for software and system project is to look at all of these functions that I'm going to be installing for a software. Let me go and think how much, let me go and think about every portion. Let me go and think about every function that is basically going to be delivered there. Let me think about how complicated every function is. And depending on whether it's a very complicated, not very complicated, less complicated, I'll be able to start really understanding how many function points I need to go and deliver and how much it's going to go and cost me as an estimation, because I already know how much each function point is going to go and really cost me. Look at the apportion method that I've told you earlier. I have a total project will cost me 500,000, but if I go and look at this 500,000 and I apportion that ratio to the various sections of the project, I know design is 20% of 500,000, so that's $100,000. And I know that D1 and D2, D1 is a 10% of that 20, and D2 is 10% of that 20, which means D1 is 50,000, which is 10% of that 20, and D2 is 10,000, 10%, which is 50,000 of that 100,000. 30% apportion to the 500,000 of the 30% is 150,000. And then when I go and say, 20% of that, 30%, if 30% is 150, then at 20% of the 150, so sorry, then 20% of that 30%, so it'll become $100,000 because every 10% is 50, 50, 100, 150. So 20% is basically 50, 100, which is that a portion that basically I went and I actually had here from the main ratio that we had available. Any questions, my friends, at all?
All good, sir.
All good, no worries.
I really appreciate it.
No worries, you're very welcome. Guys, I want you to now start doing the exercises. And I told you there's always going to be exercises we need to go and do. And it's basically continuing from what we do every week. But the only difference is now all of those calculations will be interlinked. So what I cover here today is going to be the same building on next week. It's going to be building on a week after. And it's very, very important for you guys to be able to start working on those exercises. Now, I've just explained to you a couple of approaches. Specifically, I think this will be more about what I've basically covered here, something more like relating to the apportion methods. So I want you to now go and read Open Tutorial 3 file, and I want you to start working individually on exercise 1 and exercise 2. I will give you 10 minutes for this exercises. They should not take more than that. If you finish earlier, please make sure you send a message so that I will know that you finished and will be able to go and proceed very quickly. But for those who are coming here for the first time, I want to go and open Moodle for you. So you can see on Moodle, I have available on Moodle. You can see that if I go a bit down, you go to tutorial number 3. By the way, I've already put the answers for tutorial 2 and tutorial 1. So make sure after you've reviewed already your extra work that you've had to do, make sure you go and compare to your answers. And if I go and show you here, there's tutorial 3 that is available. You need to open that tutorial now. And you're going to be able to go and get some exercises in front of you. So what I want you to do, I want you to then open exercise number 1. And I want you to do that exercise. And then I want you to give you exercise number 2, which is a bit easier. And then I want you to do that exercise. So we're not in a hurry. The most important thing is that you spend the time learning every calculation I'm giving you. And the most important thing is any extra calculation you have to go and be doing at home to be able to go and make sure you're doing that at home. And you check the exercises and the result after. So for now, I want you to open the tutorial 3 file. I'm going to give you as a minimum 10 minutes because it might take you longer than that. And I want you to start working on those exercises. As a beginning, these are very easy exercises. For the other ones, we're going to start putting some drawboard in front of you, and we'll start talking about that very shortly. But for now, let's start working on those exercises. I'm giving you 10 minutes, guys. Thank you very much for all your hard work. All right, guys, we've given you some time to be able to go and try to check your exercises for the first one. I can see we're getting so many answers. So let's just go and start going on to that first exercise. The first exercise, talk about Mrs. Tolstoy and her husband. They talk about a house they're trying to go and build. And it's saying, what is the estimated cost for the Tolstoy's house if they use contractors? So if they want to employ someone, and if the house is 2,900 square feet, and if they will be charged $120 per square feet, how much would the actual house cost them? How much will it cost them? Anyone?
So June 2090 times 120.
It's 2,900.
Yeah, 2,900 times
920, correct. That will tell me it's going to cost me how much?
348,000.
348,000. That's a very, very well done. Thank you very much. Then they ask us another question. Okay, they say, estimate what the cost of the house would be if the Tolstoys use their talents to do some of the work themselves. Now, what does Mr. Tolstoy do?
That's plumbing.
What's that?
Plumbing.
Plumbing. Okay. And what does Mrs. Tolstoy do?
Interior decorating.
Okay, great.
Yeah.
So out of all of these, I want you to tell me which one of those jobs could be done by Mrs. Tolstoy or by Mr. Tolstoy. Can they do the excavation?
No.
Can they do the roof?
No.
What can they do? What can he do?
Plumbing.
Which plumbing?
Fixture installed.
Okay, so we have here, we have the plumbing fixture installed. That's one of them. That's 4% of 348,000, which is 2,900 times 120. And what else? What other plumbing can he do?
Plumbing rafts in.
Okay, so that's 6% of 348,000. And what could she do?
Interior
Can-
decorating.
Which is 4% of 348,000. So what is 6% of 348,000? What is 6% of the budget? What is 6% of 348,000?
2,088.
20,800.
20,000, sorry.
Okay. What is then, what is the 4% of 348,000? Yeah, thank you.
13,920.
Correct. Thank you very much, Rishti. And then we have again another 4%, which is for the interior decorating. That's 13,920. So they can actually save this amount, which is 20,880 plus this amount, which is 13,920 plus this amount, which is another 13,920. So overall, they could save $48,720. How much was the original project going to cost them? The original project was going to cost them $348,000. And if we want to know how much it's going to cost them now, after they've done some of the work themselves, you would do 348,000 minus 20,880, which is 6% we spoke about earlier. Just put it again. Minus the 6% we spoke about, minus 13,920, which is a 4% we spoke about, minus another 13,920, equal, it's going to be, the total is going to be, anybody could tell me? Before more put in it?
299,280.
What's the total is going to be?
I did.
What's that? Anybody calculated the total? I know one of you did. Tasmia, what's the total?
Yes, sir. 299,280.
299,280, which is after we do the savings, that is how much a project is going to cost me. Does that make
Yeah.
sense?
Yes, sir.
Is it difficult, guys? Do you understand it?
Yes.
Is this a portion method? Is this a ratio method? What is it? What method is this? Anyone? Or my friends? That is the apportion method that I spoke to you about earlier. You see how we're talking about all of these percentages in comparison to the overall project cost. Does that make sense? Are we clear?
Yes, sir. Clear.
All right, let's move to the next one. The next exercise I gave you was this exercise here. And again, this is a work breakdown structure. The total project is going to be 600,000. Now, I want you to bear in mind that the 600,000 is divided 50, 40, 10. And that 10% is divided into 6 and 4. So the 6 and 4 is for the total 10%. So if we know that the project will cost me 600,000, and if I know that design is 40, what is 40% of 600,000? What is 40% of 600,000? Come on, guys. Thank you, Shrishti. Yes, it is $240,000. Now we're going to talk about something else. We're going to talk about programming. Okay. So we know that programming is 20%, which is, 50, if you want, design is 40, programming is half of it. Programming is 20. So if design is 240,000, and if programming is 20%, which is half of the 40, how much is programming going to cost me?
120.
120,000. And if we talk about in-house testing is 40% of the overall project, which is 40% of 300,000. How much is 40% of 300,000? Sorry, 40% of the 50%. So if the 50% is 300,000, how much is the 40%?
240.
It's 240, because this one, if the 50% is 50% of this, that's 300,000. It means every it means we're going to go and divide it in 60 each. Every 10% is 60. 60, 120, 180, 240, 300,000. So that's for 50%. Every 10% is 60,000. If I have 40% of the 50%, that's mean I have four times. I have 4 times 60. That's 60, 120, 180, 240, which is that's the answer for that particular item here.
For like, I got confused. Like, we are not doing the 20% of the design, or we are doing for the total amount for programming.
Are you okay? Programming. Okay, this is design is 40. Yeah.
Yeah.
This 40 is split here. 20.
Yep.
30, 34, 37, 40. So when I say the 20, that's half of the 40.
Yeah.
Does that make sense?
Yep.
Any other questions, guys? Anyone else? Any other questions?
Oh, good.
All
So I
right.
think that is the weakness in the inheritance.
And what, sorry?
Answer for the question B.
Yeah, what are the weaknesses? The weaknesses is if your historical data, if that data is wrong, would this data become correct? If that's wrong, would this be wrong?
Yeah,
Yes.
everything will be wrong.
That's a weakness. If the total cost estimate is off, every other cost is going to go and actually off. The only way we could get this method to go and work well, if we have correct historical estimation. Without a correct historical estimation, things are simply not going to go and actually work. Projects must be very similar to the past projects we're doing, because otherwise, if you're going to actually be getting that estimation method to be used, it won't actually give you the right outcome. Does that make sense?
Yes.
All right, amazing. Now let's go and continue with further information. We've already done this exercise. Now, this is a function point I was talking to you about earlier. I said, when I have to go and do some work, I have to go and think, what input the system gonna have, input is the input screens, what output screens, what inquiries we're gonna have, what files we're gonna have, what interfaces we're gonna have. All of these things have various type and amount of complexity. By us considering all of these complexity that might be existing at any particular point of time, then we are actually able to go and get the right estimation to go and really go and be delivered. When I talk about the bottom-up approach for estimating project times and costs, there are other methods we need to go and really bear in mind. And when I talk about these methods, we talk about things like the template method, the parametric procedures applied to specific tasks, the range of estimation, or a combination of each. When I talk about a template, for example, let's say we want to build a house. We have all of these activities on the template. We put a time for each activity. We put a cost for each activity. We assign a resource for each activity, and we basically be able to go and get our estimation done accordingly. Or if we go and talk, let's say, about the parametric procedures applied to specific tasks. Let's say we have a small task in a software development, and let's say that small task requires 10 times repetition of one task. And let's say that every task we're going to do it's going to take 1 day, and the 10 times repetition is going to take me 10 days. We can use that parametric estimation. We say, okay, that one small task is going to cost me $100 per day. It's going to be for 10 days. That means it is going to cost me $1,000 for all of these 10 days period. So we kind of apply it in that particular manner. There are other methods. There's a PERT estimation, which starts thinking about optimistic estimation, pessimistic estimation, most likely estimation. We start using calculations to be able to get our estimates correct accordingly. That's something we, another approach that sometimes is actually going in use. But a lot of times people might use a combination of more than one approach together to be able to go and get an estimate. You might use a template as well as, let's say, a parametric procedures together to be able to make the estimation. That's the example I showed you earlier. This is an example of the what we call the PERT method, which is the various estimation. You have a what we call a low estimate, optimistic estimate, most likely estimate, and pessimistic estimate. And what you'll do, you'll be able to go and use a calculation formula to be able to go and get your range estimate here. The way that we do it is we make one time optimistic plus 4 time most likely plus 1 time pessimistic divided by 6. So if I was to go and use this numbers here, 1, 1, and 3, the way we do it is we say, okay, we'll say something like 1 time optimistic plus, that's not, actually, let me see if I can do it a different way. 1 multiply optimistic plus 4 time most likely plus 1 time pessimistic, and I divide the whole thing by 6. And if you go back and you look at what we've had the optimistic, we've had it as 1 day estimate, which means 1 multiply 1 day estimate. The most likely we've had it as 1 plus 4 times 1, and the pessimistic we've had it 3 plus 3. All of this, we divide that by 6, so equal 478 divided by 6, which basically will say equal 2 days for me to be able to go and complete that particular task, because we're using the optimistic 4 times most likely plus the pessimistic divided by 6. Now you're going to say, why divided by 6? Because you're making 1 time optimistic plus 4 time most likely plus 1 time pessimistic. So to get the average, you need to count 1 plus 4 plus 1, which is 6. And that's basically what you divided by at that point of time. And that's really what I'm talking about here in terms of how they did their calculation in this particular example to be able to get all of these various ranges that are available here in terms of the estimation of each activity. So that's the optimistic, that's the most likely, and that is the pessimistic estimation. Does that make sense? Does that make sense? Take that. Yep. All right. Thank you guys for all the thumbs up. Now, guys, there's so many costs we need to think about when we're talking about managing projects. We're talking about direct costs. We're talking about, indirect costs. We're talking about overhead costs. We're talking about admin costs. The direct costs are costs that you're going to be paying to be able to go and work on a particular task in a project. Labor task, material task, equipment task, all of these things are direct costs associated with doing the job. Overhead costs, costs incurred that can be tied to a deliverable. So when I pay a salary for a project manager, for example, when I pay rent, when I pay supply, when I talk about specialized machinery that I need, these are overhead costs that can be tied to a project deliverables. We cannot get the job done without a project manager, for example. We cannot get it done without having a place and renting it, as an example. And finally, there's general and administrative overhead costs, organization costs indirectly linked to a specific work package that are apportioned to the project. For example, you might be having someone who's doing admin and accounting for the project, maybe let's say 2 hours a week. And this is the overhead cost that we basically apportion that 2 hours as a cost potentially associated to that particular project. I want to say thank you very kindly for bearing with me in that first chapter. We are now going to continue with the biggest and foundational further calculation that we need to do. This is really, really important calculation. You must know everything about that calculation to be able to go and really do well in many of your exams that are actually going to be coming up. So pay a lot of attention. We are going to be talking about developing a project schedule. Now, ladies and gentlemen, now I am going to be talking about the developing a project schedule subject, which is a chapter. It's a very important subject for your assignment and for, everything else you're going to go and do in terms of planning after this week. So if you want to do the schedule, you start with a schedule, then you create a budget, then you create all of these other things that needs to go and really bear in mind. So it's about really thinking about all of these various foundations that I'm trying to go and now teach you to be able to help us to get the right scheduling. So it's really talking about creating a project network, which is really the first things in terms of what you need to do to be able to create your scheduling after creating obviously the work break and structure, which is all the tasks that needs to go and be completed for a job to go and be done. We're going to go and understand the linkages between a work breakdown structure and a project network. We're going to talk about, how do we create a diagram, which is diagramming a project network using activity or node method. We're going to calculate early start, late start, and slack time calculations, which is basically the foundation of a lot of the calculations that you must know how to do, possibly for your midterm exam, possibly for your quiz, and for your final exam. We can identify and understand the importance of managing the critical path, and we're going to try to distinguish what is free slack and what is total slack. Now, when I talk about a project network is really a graphical conveyance of all the tasks that needs to go and be completed for a project. So the project network, it's really a flow chart that uses the work breakdown structure information. Now, guys, can anybody remind me what is a work breakdown structure that we spoke about last week? What is a work breakdown structure? Do you remember? Anybody? If I say I am going to be, if I say I would like to go and get a master's of IT, how do I create, if that's my goal, how do I create a work breakdown structure for that goal?
Completing 16 subjects.
Okay, so we spoke about that. We spoke subject 1, 2, 3, whatever. Okay, and if we're talking about subject 3 being project management, what do I need to do for that?
I need to complete my quiz, midterm and final term and assignments, each and everything.
Exactly, midterm, final. And if you would like to go and finish the quiz, I need to go and make sure I attend my lectures, I take notes, I revise, all of these things. And for every one of these activities, I'll assign people to be able to create my schedule. So when I have all of these listing here, that's what I call a work breakdown structure. But a list is only one thing. I need to know when does each activity start and when does each activity goes and finish. So I need to create a network diagram to know what is the sequence of each activity that we need to go and complete at any particular point of time. So a project network is a flow chart that uses a work breakdown structure information and graphically depicts a sequence, interdependencies, and start and finish times of the activities that are available throughout the network. So when does something's going to go and start? When does something going to go and finish? And so on. We need to know all of this information to be able to go and manage all of these activities and know when things are going to start and know when things are going to go and really be finishing. So what a flowchart does, it provides the basis for scheduling a labor, scheduling the equipment we're going to have. It basically helps us enhance communication among people in terms of the project participants, because they can clearly see when things are supposed to start, when things are supposed to end. They can see the start time, the end time, and so on. It provides an estimate of the project's duration. It provides a basis for the budgeting, because when I go and say, for example, I need to do, if I go, for example, and say here, I need to go and let's say, study for the exam, that is a very particular activity. Imagine this is a job, okay? I'll need to assign a person at a specific time. And at a specific cost. So when you have this, this activity, and let's say there's another activity here, if I go and combine the costs here and the costs here, I'll be able to have an overall costing across more than one duration. If I combine the time here and the time here, I'll be able to get a due date for more than one particular requirement. So it's about really looking at the various things that we're trying to go and do at any particular point of time. So it provides a basis for budgeting cash flow. It basically identifies which activities are on a critical path. A critical path activity is an activity that cannot be delayed, because if you delay that activity, it is going to go and delay the end time of that particular project. That's going to go and basically start costing you money. It highlights the activities that are not critical. In other words, any activity that we can delay without really delaying the end time of our project. So that's something we can actually go and do. And what it does really, it helps us to be able to go and stay on plan at any point of time in terms of what we're trying to go and do, because we can compare how we are progressing in terms of delivering the tasks that we need to go and really be completing. So something to go and really continue bearing in mind, guys. Now, I want you to look at them. A work breakdown structure will have all of these work packages. I have specification, I have documentation, prototype, final prototype, testing, software preliminary, and software final version. However, all of these work packages don't tell me when they need to start and when they need to end. These are simply items of the work breakdown structure. What I need to know now, when does each item need to start? So you can see, for example, specification and documentation, it needs to start first. Prototype and software preliminary needs to happen next. Final prototype needs to happen after those two are happened. Final software needs to happen after the final prototype. Testing needs to happen after all of these other items have already been completed. So that is the sort of things we need to go and really be looking at in order for us to be able to go and get the job to go and really be completed. So when I'm talking about all of these activity, what comes first, what comes after, and so on, we need to go and start thinking about what do these terms mean that are relating to each one of those particular activities. So there are all of these terms we need to really know about, and we need to. All right, so we talk about an activity. What is an activity? An activity is an element of the project that actually requires time, something that is going to take me time to be able to go and complete. A needs time, B needs time, C needs time, D needs time in order for a job to go and really be completed. What is a merge activity? An activity that has two or more preceding activities on which it depends. So D has A and B before it, and it actually depends on both A and B. So D cannot start until A and B has actually been completed. So D starting is dependent on A and B actually being completed. That's what we call a merge activity. Can you guys see another merge activity here?
Yes, D.
Which one? D. And what is it dependent on?
It depends on C and B.
C and B?
Yeah, it also depends on A.
Correct. Absolutely. All of these. Correct. What is a parallel activity? An activity that can occur independently and, if desired, not at the same time. So I can do A and B at the same time and C and A at the same time, but there's nothing that says you must do A and B at the same time. There's nothing that says you must do C and D at the same time. So you need to basically go and try to look at those particular components, how it gets done. But they could start at the same time, but they don't necessarily have to go and really start at the same time. A path. A path is a road. It's basically a sequence of connected dependent activities. So here I can see how many paths. I can see AD is a path, BD is a path, and B and C as a path. Here I can see two passes, C and D as one path, and A, B, and D as one other path I need to go and really bear in mind. What is a critical activity? A critical activity is an activity that is on a critical path. The critical path is the longest path through the activity network that allows for the completion of the project-related activity. In other words, it is the shortest time for the project to go and really be completed. Any activity on a critical path that is delayed, it is going to go and delay the end time of the actual project. What is an event or a milestone? It's a point of time in which when the activity is started or completed. So if we come here, we mentioned earlier, we need to do many, many tasks, prepare, study, study, sit the test, attend a lecture. Okay, all of these. And finally, after everything is done, I would say quiz complete. Quiz complete is what we call a milestone. It does not consume time. Okay, it's basically telling you that something specific has been completed now, something that is particularly significant for us in terms of the project that we have. So that's what we bear in mind in terms of the milestone. An event in time when an activity is started or completed, it actually does not consume any of our time. What is a burst activity? A burst activity is an activity that has more than one activity immediately following it. Okay, so when I say an activity immediately following it, it's basically after it, there need to be more than one activity that we need to go basically and bear in mind. Can you guys tell me, where do you see a burst activity? Where is the burst activity? What do you think? So as I said, the burst activity is an activity that has more than one activity immediately after it, more than one dependency error flowing from it. Which activity have more than one error flowing from it?
X.
100%. So anything that basically comes after X, there's two errors flowing from it. What we talk about this is a burst activity. Y and Z are preceded by X. X is a burst activity. Y and Z can begin at the same time, but do not really need to go and actually begin at the same time. Does that make sense?
Yes.
Now, can you guys tell me, where can you see a merge activity here? Is there a merge activity here? Can you see any merge activities in any of this graph in front of you?
Yes, a lot.
Okay, which ones?
JKL is merged to M.
No, that's not a merge activity. Where the merge is when two things are merging into it.
Oh, sorry.
So M, there's three arrows merging into it. Anything else you can see merging?
J
M
and K only merge into M.
J is another, sorry, Z. Look at Z. There's two arrows merging into it. And AA, there's two merging into it. So Z, AA, and Z, all of them have activities that are merging directly into them. Can you see any activities that could be started at the same time? Any activity that could be started in parallel? Can you see any? Come on, guys.
JKL
Absolutely.
all are individuals.
They could start at the same time, but they don't have to, but they can. And X and Y, they can
X
start
and
at
Y,
the same
yes.
time, but they don't have to. Can you see any burst activity? In other words, there's 2 arrows going from an activity for an activity after it. 2 arrows from one activity. Can you see any burst activity? An activity that has
XY.
X and Y. X have 2 Z and AA after it, and Y have Z and AA after it. That's very, very well done. Let's start getting ready for the calculations. You're going to have to do the first calculation before I start talking numbers. So I'm basically splitting it one piece at a time. Now let's look at this graph. I want you to look at this graph here first. Just give yourself a few minutes to observe it. So what is this graph telling you guys?
How much time each gonna take for their activity?
Great. It's telling you how much time each activity is going to take. Okay. So A is going to require 5 minutes. What else is it taking you? What is it telling you? What does this mean?
What activity needs to be done before you?
Before it. So is
Done.
there any
Yeah.
activity
Yeah.
that needs to be happening before activity A?
Yeah, no.
No. So the first arrow, the first network diagram that I need to put is what? So the first box that I need to put here is what?
A.
A.
That's A.
Yes, sir. Yep.
Can you see A? That's first. Activity A, they're putting in the box here. This 5 means the duration of the activity. This here, application approval. This is describing the activity. And there's all of these other fields that I'm not going to talk about now, like ES, EF, LS, LF, SL. I'll talk about them in a minute. I'll explain them to you further what they mean. Okay. But do you understand the first basic component? Do you understand that A needs to start first and why it needs to start first? Anybody doesn't understand that? Okay. Guys, now I want you to tell me what should come after A. I want you to tell me every activity that must be done after A.
B, C, D.
B, C, D. So it's
Yes.
saying before B could start, A needs to be finished before it. Before C could start, A needs to be happening before it. And before D could start, A will need to be happening before it. That's correct. So there's an arrow from A to B because B will happen after A has finished. Same from C. Arrow from A because C will start after A has finished. And the same thing for D. The same thing again. B, construction plan, that's a description. 15, that's a duration. And B, that's the actual description or the ID of that particular activity. Now, what's going to happen after B, C, and D? What would we have?
We can go for E as well and
E?
F also.
Okay, so E will be after B and C. And then F will be after B, C, and D.
Yeah.
And what will happen? And what will come after F?
G.
G.
G. Okay, so after F, there's G. After B, C, and D, there's F. And after E, B and C, which is here, there's E. Does that make sense? You can see the arrows, how they're coming. Does that make
Yes.
sense?
Yes, sir.
And finally, what is there?
After G, we can have H.
You can have H. Does that make sense?
Yes, sir.
Anyone not clear?
Yes, sir.
Now that same drawing is what is going to be done by you now. That's going to be my attempt to kind of build your knowledge slowly. And then I'll take you one step further by explaining to you the further calculation, but just one step at a time. Go with me as I go every week. I'll slowly get you where I want you to go and actually get to. So I want you to now open the tutorial 3 file again, and I want you to attempt exercises 3 and exercises 4. And all what exercises 3 and 4 are asking you to do, they are simply asking you to just draw the activities, tell me what is a burst activity, tell me what is a merge activity. And again, you need to be doing another drawing here. Very, very simple, nothing complicated. Just, I want to make sure you guys could draw the network diagram, and I want to make sure that you guys are able to go and know what is a burst activity and what is a merge activity. So let's maybe, let's try to share. Have you opened the tutorial in front of you guys now?
Yes, I have.
Okay, let me just try to see if I can. All right. Okay, let's go here. Let's go to the whiteboard. All right. So I'm going to try to make some sort of whiteboard sort of drawing. If I can get you a box from here. Let's draw a box. Okay. So let's say that's the first box. Okay. I want you to go and look in front of you and tell me from looking at that document, that is tutorial document, what should be first? Which activity?
A.
Okay.
First A.
Sorry. That's correct. Just give me 1 second. I'm going to just make all of these boxes so that I'll have them ready. Okay. So you guys told me I need to have A first. I'm going to say that's an A. And what comes after A?
B.
Okay. So I'm going to basically put this as a B. And I'm going to go and let's say I'm going to draw an arrow between, actually, it's not the best arrow. I'm going to draw an arrow between here and here. Does that make sense?
Yeah.
Okay. And then after, what do I do?
After B, you can connect C.
Okay, so I'm going to make between here, I'm going to make a C. I'm going to put a text. I'm going to say, okay, that's a C. Okay, what else now?
You have to make 3 lines for D, E, and F after C.
Okay, after C, you said I want to do D, E, and F. So let's say I'm going to say that's a D. And let's say that's a E. And let's say that's an F. And you said, you told me we need to make a arrow. So I'm going to make an arrow between here and here, and one between here and here, and one between here and okay, let's just leave that. And another arrow between here and here. Okay, so that's what you guys told me so far. You said we need D, E, and F after C, and what do we do after?
D, E, and F will merge to G.
Okay, so I need to go and put one here
Yep.
after it, and I need to kind of name that a G. I need to go and make an arrow.
From D, E, and F.
D, E, and F. And what's the last thing I need to do?
H.
When I select H, guys, just to let you know, usually I like them to all be on the same line. So just but there's no space here. So just when you are drawing it in front of you, just make sure you have enough space and draw them all on the same line, not like this on separate lines. But you understand what I'm talking about here. So here you make a final arrow between G and H. So H is the end. That's a H. And I would have done every single activity here. Does that make sense? Is that clear?
Yes.
Okay. Now the
Yes.
question is asking you, any questions? Sorry.
Oh, good.
Okay. So the question is asking here, what activity is a burst activity? Can you see any burst activity here?
C.
Absolutely. See, there's 3 arrows coming from it. Can you
See.
see any merge activity?
Yes, sir.
Which one?
G is a merge activity.
G is a merge activity. Does that make sense?
Yes, sir.
It's not that hard, is it?
It's very easy.
All right. So now I want you to go and I want you to do the second exercise by yourself. I'm not going to say anything. And I'm going to actually start preparing for potentially the next exercise we're going to go and do. But yeah, I want you to continue doing with what we've done so far. And I'll try to prepare your file for the next exercise. But just do the other exercise by yourself. Think I'm not here. And let's see what you're going to do. All right, guys. So we gave you that other exercise that I want you to go and look at. And the exercise asked you questions. And this question related to another drawing and a merge activity. So I want you to tell me for exercise number 4, I want you to tell me what is a burst activity there.
A is a burst activity.
A.
Okay, and which activity is a merge activity?
G, F, G, H.
That's correct. Now, what I want to let you know, those exercises that you just did in 3 and 4, what I usually go, if we have more time, sometimes I assign a duration for each of these activities, and I tell you to start drawing the network diagram. So if you have done that on a paper, I recommend you leave it because I might give you an exercise later if we have time that is remaining available. But you guys are doing so good. I'm really, really proud of you. Just continue working hard. And you're going to be able to hopefully get a very good outcome. Let's continue talking. Now I need to teach you about the calculation. You know how I showed you here before? I showed you these things here, ES, EF, LS, LF, SL. That's what I'm going to teach you. How do you actually calculate now so that you can do it in your exams, you can do it in your quiz, you can do it in anything that you need to go and do. So what is ES? ES means early start. What is EF? EF means early finish. What is ET? ET is estimated expected time. What is ES is how soon can an activity start? What is EF? How soon can an activity finish? What is ET? How soon can a project actually go and actually finish? So 3 important item that you need to go and bear in mind. Great. What about the backward? This is when I'm going forward. So when I'm going forward, we talk about this, we talk about this, and we talk about the expected completion time of a project. When you're coming backward in our calculation, so we calculate things forward. So we calculate this, 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 this. We calculate only the ones on top. When we going backward, we calculate the items that are at the bottom. So the bottom, 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 bottom. We calculate all the bottoms that needs to go and really be completed. So when we're going backward, we calculate the latest start, latest finish, slack, and the critical path. Latest start is what is the latest time for an activity to start. Latest finish, how late can an activity actually go and can it go and finish? And the slack, how long can an activity be delayed without delaying the project end date or the start date of the next activity. And what activities are in critical path, which mean which activities cannot be delayed, because if we delay it, it's going to go and affect the end date of our project. So that's what we basically go and talk about. So let's go and continue further. Total slack is the amount of time an activity can be delayed and not actually delay the project. That's the amount of time activity can be delayed without delaying the project. Slack, which is free slack, is how long an activity can exceed its early finish date without affecting the early start of any activity after it. So the free slack is the slack that won't affect the start date of the activity after it. And the slack is an activity that could be delayed, but if you delay it, it doesn't actually finish and affect the end date and end time of the project. So one is focused on the activity after it, and one is simply focused on the end activity at the end of the particular project. We talk about sensitivity, the likelihood that the original critical path will change once a project is initiated. The critical path is a network path that have a zero, a slack, or usually actually the least slack, which is usually you have a zero slack. In other words, they are activities that cannot be delayed, or they basically have very little slack time. And if that slack time has been used, it's going to go and make the project much more harder to go and manage, because the activities, in other words, so many activities, starts becoming critical and starts becoming the activities that we cannot actually go and delay. So we need to think about all of these slack. We need to calculate the slack and to be able to understand which activities are in a critical path. This is only now introducing the concepts, but you're going to see with an example how things will go and actually get applied in details. Okay. All right, let's continue, guys, with this calculation. So let me teach you how do we calculate the calculation that we need to go and do. Guys, the first thing we need to calculate is the early start. In other words, when is the earliest time we could start an activity? When I say the earliest start plus the activity duration, I can get the early finish of a particular activity. So 0 in this example, which is the early start. What's the duration of activity A, guys?
12.
12. So 0 plus 12, what does it give me?
12.
Which is what? Which is
Earliest start time.
your early finish of that activity. So the early start, which is the earliest time the activity could start, plus the duration, plus 12, you give you the early finish of the activity after it. So it gives you, in that example, gives you 12. Does that make sense?
Yes, sir.
Now, the early finish, this early finish becomes the early start for the activity after it, unless rule 1, which I'll talk about now. But if that is 12, that activity, when does it start? After 12. This activity will start after 12. This activity will start after 12. So it finished 12, it start 12, and then we'll start adding the extra durations to it. Unless there's rule 1. What is rule 1? Unless the activity is a merge activity. When there's a merge activity, you use the largest early finish. So this activity J is a merge activity. It has 3 early finish before it. And to be able to know which one is going to be the early start for activity J, we have to look at this rule, which says we need the, we need the actual largest early finish. So the largest early finish between this, in this, becomes your early start for the activity after it. Now, people might ask me now, why do we use the largest early finish? Because our purpose is to find the longest time the project is going to be taking. If I'm not going to be using the largest early finish, I won't get the largest early finish here at that particular point of time at the end of the project. So we always use the largest early finish when we are moving forward in our calculations. Let's give it a go. Guys, what do I put here? What's early start here? Giovanna.
Yep.
What do I
0,
put here? 0. What do I put here?
0,
And here?
12.
12. 0 plus 12.
12.
Give me early finish of 12. Make sense?
Yes.
Okay, Fidak. Fidak, can you hear me? Okay, Farouk, can you hear me? Farouk, Fidak. I need you guys to be focused. This is really important because you need to do the calculation very shortly. And that's definitely in your exams. Tasmia,
Yes, sir, I'm here.
what's here? What do I put here?
9, sir.
Here, in this box here.
Network computation process content.
When does the activity start?
Early finish.
Yeah? No.
Yeah.
That's different. Remember, this are in parallel.
Yes.
So these could start at the same time. So
0.
0. 0 plus duration of 9. What does that give me here?
9.
Early finish 9.
9. Okay. Niraj,
Yes.
what do I put here, my friend?
Start is 12.
Okay, so 12, which is the early finish, becomes the early start. So that's 12 plus.
15,
What does
27.
it give me? 27. Muhammad,
Yes, sir.
what do I put here, my friend?
12, sir.
12 plus.
10, 22.
Perfect. Thank you very much. Farouk, Fidak, are you guys back? Okay, guys, who else could tell me about the third activity? Activity C.
Same 12 plus 10, 22.
Correct. Now, what about for D?
It's for 9
9 plus 10.
19.
Okay,
90.
what about for E?
It will be 9 plus 4, 24.
24.
All right, so let's just
33.
go.
Yep.
Let's go and kind of pick up on these items. All right, so you guys told me 12 plus 10, 22, 9 plus 10, 19, and 9 plus 24 is 33. Now let me ask you, what do I put here?
23. 22 plus 35.
22 plus 35 is?
57.
And what about here?
19 plus 40.
1940.
Okay, that's 40, 59. Okay, now, this activity
Mm-hmm.
is what sort of activity?
Merge.
Merge activity. So for the merge activity, we have 3 early finish. Which early finish do I use?
59.
59. Why
Oh, lower.
59?
Because it's the highest, like the
Highest.
largest early finish.
Correct. And that 59 plus 4 gives me?
63.
63.
And K is another merge. So what do I put for K?
27.
Highest one.
Look again.
63. Yeah.
Absolutely, because there's 27, there's 22,
22 and 63.
63.
Oh, so
The
yeah.
highest is 63 plus 6 gives me
69.
69.
69.
So
So what's
didn't
the
observe the
estimated time of the completion of this project?
69.
69. Very, very well done. That's basically what we basically did so far. Now we need to go and start talking about the backward calculation. But does anybody have any question about the forward calculation?
All good, sir.
All clear? Everybody's clear?
I'm good.
All right. So we have the latest finished. So that's the latest finished. Okay, this is here the latest finished. Okay, so we say we need to have that early finish becomes your latest finish. So this 69 as an early finish becomes your latest finish. Your latest finish minus duration give you the latest start. So what's the latest finish? What do I put here?
69.
69.
69, because it's the early finish. Minus duration, minus 6, what does it give you?
63.
Okay, give you the 63. That's correct. So 69 minus 6 give you the 63. Now, the second thing is we carry the latest start to the activity before it, and it becomes a latest finish. So this 63, which is the latest start, it becomes the latest finish of the activities before it. So what do I put here?
63.
63.
What do I put here?
63.
63.
And what do I put here?
Down. Yeah. 63.
Okay, 63 minus 15 is what? Whatever it is.
48.
3 minus 10 give me 53.
53.
And 63 minus 4 give me 59. Does that make sense, my friends?
It does.
Anything difficult?
Not
good.
sir.
Okay, now that 59, where does it go?
Here for 33, like E and G and H as well.
Yeah, E, H, and G. That's correct. So 59
Yeah.
minus 35, give me 24.
24,
59 goes here, gives me 19.
19,
And 59 goes here, gives me 30.
30.
Now, this 24, where does it go?
For C,
And what do I have before?
14,
And this 19, where does it go?
D,
And what do I have here?
9.
9.
9. Okay, now what happens here?
It's for
This is a called what? What sort of activity?
merge. It's
This
coming
is
out of
Burst.
burst one.
Okay, let's look. The next succeeding activity is a burst activity, in which case the smallest latest finish of all preceding activities. Okay, so let's actually this should be the latest start.
It will be 14.
But the smallest, yeah, the smallest is
14, yep.
14. So this 14 goes here. And what do I put here?
The same one, 9.
9.
9. So the 9 goes here. 9 minus 9 equal what?
0.
And here, and here, what do I put?
14.
12.
Minus
2.
14.
Okay,
2.
minus 2. Does that make sense?
Yeah.
Anybody not clear? Anybody have a question?
No, I'm good.
All right. The final things we need to do is we need to calculate the slack. In other words, which activities could be delayed. The way you calculate it is you make, you make this formula, latest start minus early start, or latest finish minus early finish. So latest start of 0 minus early start of 0. What's the slack here?
0.
What's the slack here?
0.
What's the slack here?
0. 0.
0.
Here?
0.
Here?
All 0.
Okay. So 0, 0, 0, 0. What's the slack here?
2.
What does a slack of 2 actually means?
Time or
What does it mean? What does slack? I explained to you earlier what slack means. What does it actually means?
Delay can be made.
I can delay this.
It won't delay the project, but
Won't delay the project. 100%. That's 100% correct. Now, what is the slack for this activity?
36,
Correct.
48 minus 12.
53 minus 12, 41.
41,
14 minus 12, 2. 35 minus 9, 26.
26,
24
2.
minus 22, 2. And that's it. Now, which activities
Okay.
have zero slack?
B,
D.
D,
B, D,
D,
H,
That's JK.
J, K.
Which mean B, D, H, J, K is my critical path, which mean if I delay any of these activities, the duration of the project is going to go and start increasing. Does that make sense?
Yes.
Yes, sir.
Can you find any activity which are sensitive, which basically we call it a sensitive pass? Activities that don't have a lot of slack.
A,
A, C, and G.
A,
A, C, and
C,
G. They
G.
only have 2 days, 2 days, 2 days of slack, which mean these activities could very well become another critical path if these slack basically become used. Does that make sense?
It does.
Alrighty. Are you ready for some fun calculations now to apply what I've just taught you?
Yeah.
Yep.
Yes, sir.
All right, guys. So open the tutorial 3.5 and attempt exercises 5 to exercises 8. I would say I'm going to put it here for you so that you guys will see. I'm going to actually work in this first one with you, and then I'll let you work on the next one by yourself. So open it in front of you now. Let's open the board. So which activity is first, guys? When you go and look at that activity that I just showed you, which activity is first?
A,
A. And after A, what do I have?
B,
D,
B.
So I have activity B after A. And what do I have after B?
C,
C and
G.
D.
C and D. And what do I have after C and D?
E.
E.
Okay. Can you guys, you can see what I'm drawing, yeah?
Yes.
Yes.
Okay.
Okay. So I have now A, B, C, and D. I'm gonna just, it's not gonna be perfect, but because I'm gonna use lines and things like that. So it's not gonna be like a, like Picasso drawing, but it'll be good enough. Okay, so let's say, okay, so let's say that's the first one. I'm gonna make that another one. That's it. It's not gonna be Picasso drawing, so forgive me on that. By the way, make sure you're drawing also, yourself now. So not simply me. I'm just trying to show you from my end so that you guys will be making the further drawing yourself. But again, I go here and that's one here. This one here. And we'll do that drawing and that drawing and that drawing. And we said you guys told me we're gonna have, you said we're gonna have, this after A. And you said we're gonna have this after B. And you told me we are going to be having this after D. And you guys could obviously put all of these details here. For example, you can write here survey, whatever it is. And you could basically say, all right, here. When, and actually, this is important here. A, we know that it has 2. I know that then Oh, we have missed a line here, drawing. I know here, if I'm going to put a text, we know that B is going to be 4. I know C is going to be 3. I know that D is going to be 5. And I know that E is going to be 3. So let me now ask you, if we are doing the forward, what do I put here?
0.
0. And what do I put here?
2.
2.
2. And what do I put here?
2.
And what do I put here?
6.
6.
Right. And what do I put here?
6.
And what do I put here?
9.
And what do I put here?
6.
6.
And what do I put here?
11.
11.
And what about here?
11.
11.
And what do I put here?
14.
14.
Does that make sense?
Yeah.
Is anybody unsure, doesn't understand? Do I need to explain something again?
Nope.
All right, perfect. Now let's go and start talking backward. So that's C. What do I call here?
Early finish.
Early finish. And what else do I call it? ET. What is ET?
Estimated time.
Right. What do I put here, guys?
14.
14.
What do I put here?
11.
And what do I put here?
11.
11.
And what do I put here?
11.
11.
And what do I put here?
8.
Correct. And what do I put here?
6.
Okay. And now I have, can you see, what is this called?
First.
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 What do I put here?
6.
6.
And what do I put here?
2.
And what do I put here?
2.
2.
And what about here?
0.
0.
Okay. Now, what do I put here? What do I calculate in this box?
0.
I calculate the slack. Latest start minus early start. 0 minus 0 equals 0. What do I put here?
0.
0.
What do I put here?
2.
What do I put here?
0.
0.
And what about here?
0.
0.
So which activity is on the critical path?
Here the A, B,
A, B, D, E.
So everything that I've basically just selected. Doesn't really give us a chance to really make it, but anyway, this activity, this activity, this activity, and this activity are all on a critical path, and this activity here is not on a critical path. Does that make sense?
Yes.
Okay, so how many days will the project take to complete?
14.
14 days. So that's basically one simple exercise that I just did now myself in front of you, just straight away. Okay. This is basically exercise 5. Now there are 3 more exercises that I want you to do by yourself without me, because if this is an exam or a quiz next week, you must be able to go and solve it yourself without my assistance. And that's what I want you to go and do yourself now.
How
all right.
many questions we are getting in the exam?
Usually in the midterm exam, usually I give you 2 calculations. In the final exam, there might be between 2 and 3 calculations. So they do change, but just roughly speaking, that's what I usually give you. There'll be full calculation exercises with so many different questions that are related to what I'm teaching you. Any other questions?
Oh, good.
Okay. Now let's continue with the calculations, guys. There's 6, 7, 8 that I would like you to be working on. Whenever you have the answers, you can share with me. You can ask me. I'll let you know if it's right or if it's wrong. You can start working on these activities straight away. Anybody who would like 5 minutes break could take 5 minutes break, and then we'll come back and they can continue with the remaining for the half an hour that we have. But anybody who doesn't want to have a break and want to continue working, you can continue working on 6, 7, and 8. And if you finish them, I'll give you even further exercises. So please start working on this now. Thank you very much for all your hard work.
This.
All right, so you're asking how do you actually go and identify the Gantt chart? The reason why they asked you for that Gantt chart in that particular example is because they drew something for you to be able to go and use. So if you go and look at this exercise here, they wanted you to go and rely on this graph. Can you see this graph here, down here? They want you to draw the Gantt chart here by showing which activities will start and when will they start. That's what they mean by the Gantt chart here. So they want you to show, for example, that identify topics will start in day 1, and then how are you going to go and build it up day 2, day 3, day 4, day 5, and so on. Does that make sense? Do you understand?
Not clearly.
Okay. These are all your activities. And this is the duration of 14 days. And when you're making the duration, you would usually do day 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and so on. So what they want you to do after you finish that activity here, they want you to go and highlight on this graph here, when does each activity will finish. So for example, identify topic, when does it finish?
1.
So they want you to have between 0 and 1, they want you to highlight here between 0 and 1 that you will be doing activity identify topic. When does research topic finish?
6.
Yeah, when does it start?
1.
No, it doesn't start in 1. When does research topic start?
In 1, no.
Okay, 0 to 1. Okay, and then 1 to 6. So they want you to kind of show that from here, which is end of 1.
1 to 6. Yeah.
1 to 6. So they want you to kind of have a drawing between 1 and 6 all the way here highlighted, that's how you go and actually do that particular activity. So you want to highlight when each activity is going to be done on that particular box down here. That is what they're asking you for in question number 8. Do you understand?
Yes.
Okay. Now I'm going to give you a bit of more work, extra exercises. So in next to activity number 3 here, I want you to put the duration of 3 days for A, 4 days for B and C, 2 days for D, 5 days for E, 3 days for F, 4 days for G, and 2 days for H. And make your calculations.
So can you tell again one time?
Yep, it's 3, 4, 4, 2, 5, 3, 4, and then 2. And then for activity number 4, which is this one here, I'm going to give you 7, 4, 6, 9, 10, and then 9, 6, and then 13. That's only for those who have already completed those activities. So I'll repeat them for activity 4, 7, 4, 6, 9, 10, 9, 6, and 13. Now, before you guys start working on something else, I want to ask, I'm going to just make a very quick question. I would like you to all answer me, please. Let me go to week 3 materials. And all right. So I want to ask a question. Who finished question 6? Please all give me the thumbs up now. I can see 1. Who else did it? Yeah, 2, 3. Who else? 4, Muhammad. Did Fidak, did Farouk, and did Tasmia also do the job? Okay, not sure. Guys, for those of you who've already done the job, I want to just show you the answers. So you can see for exercise number 6. Is that what you guys got? Just check it out, please. Is that clear? Anybody made any mistakes here that they would like to discuss with me?
All good here.
All good here. Okay, so estimated time is 45. Which one is the critical pass, guys?
ADFGH.
ADFGH, that's correct. And just a standard, this one. Have anybody finished question? Giovanna, did you finish question 7?
Nope.
Okay, just continue working on that. Muhammad, have you done that?
Yes, sir.
Okay, Giovanna, please don't look at the answer because I want you to make sure you work on it yourself, because I know a lot of people might actually go and struggle with those exercises, especially when I give them in a midterm exam. Usually people who don't know the calculations, some of them get 1/20 on a midterm exam. So it's very, very important you do your calculations and you learn how to do them. So I'm gonna just show to some of you without the recording because I'm not gonna basically be releasing the answers until probably the end of the week to give people the chance to make sure they work through those exercises themselves. But I'll just pause the recording for a minute. All right, guys, what I'm gonna do is I'm gonna leave a few other exercises for you to go and attempt during your own time. So what I would like you to know is, obviously, you had a question about the Gantt chart for question number 8. It's basically, as I said earlier, it's relating to, showing the related calculations, showing them, where's that? It's about showing that related, using that particular item here, this particular drawing here, to be able to put when an activity should start and when an activity should go and actually finish. I'm going to go and, this is one other thing I would like to go and discuss with you, show you. It's basically how a Gantt chart works. The way that it works is you would plan when something is going to start, but then you are going to be tracking your actual completion. So I plan to finish an activity in day 2. That's a baseline planning. And I actually finish the activity in day 2. That's the actual completed. Something like here shows you the remaining duration to complete the task. Something like this show you the finish to start relationships. it basically shows you the interconnections between various activities. You can see, for example, that activity, when it's going to finish, the estimated finish time. You can see how if an activity is going to be delayed, because this activity was supposed to finish here, but it's going to be delayed. If it's going to be delayed, this activity is going to also be delayed, and the project is going to actually also be delayed. So that's what it's trying to go and really show you here in terms of how things need to go and be done. I want you to bear in mind that I'm showing you here what is known as a finish to start relationship, which means an activity must finish before the next one starts. But not every activity is a finish to start relationship. There's a start to start relationship, finish to finish relationship, start to finish relationship, and their meaning would be different. Start to start means the next activity cannot start until the first one has started. Finish to finish mean the next activity cannot finish unless the first one has finished. And the final one means the next activity cannot finish until the first one has already actually started. We're not going to use them so much in the course. I will mainly be giving you finish to start relationship, but I might sometimes give you a lag. A lag means an amount of time a dependent activity must be delayed to begin or end. I might say, for example, activity 2 cannot start until 2 days after, activity 1 has finished. And if I say that, then if activity 1 finished in day 1, activity 2 cannot start until 2 days after activity 1. So activity 2 can only start in day 3 because there's a lag that I've basically went and I put in terms of the calculation. That's what we call a finish to start relationship plus a lag time plus a delay, that I want you to go and attempt to go and make some exercises relating to it in a picture that I'm going to show you in a minute. But an X Y lag means Y cannot start until 19 days after X has already finished. A lag here, this is what we call a start to start. Activity 2 cannot start until 3 days after trenching has already started, and refill cannot start until 3 days after lay pipe has already started. That's something to go and bear in mind. I'm going to show you a exercise now that I would like you to go and take a picture for, and I would like you to go and attempt it during your own time. Extra exercise. Yeah, I'm not going to give you the whole thing. I'll just give you part of it. So let me show you this exercise. Just take a picture of this exercise, guys. And have a go at it during your own time. It's almost the same of every other exercise with the exception that there's a lag time that I'm inserting for you here in that example. And you can ask me questions about it next week once you've actually had the chance to go and do it. In case I give you a lag in your midterm exam, in your final exam, I want you to try to have a go at doing that sort of calculation. Did you guys take a picture?
Yes.
Yes, sir.
Anyone didn't take a picture yet? Okay, great. Now, ladies and gentlemen, I just want to say, do you have any questions at all? But please don't leave. I'm going to go and make sure I'm finalizing your groups now. But please, for this week, review the lecture slides, tutorial materials, and the notes you've taken. Read chapters 5 and 6, and continue preparing for your weekly quiz and midterm exam. Your weekly quiz is going to be next week, so make sure you are here attending the whole session. Thank you very kindly for your time. I care about you. I care about your success. Please continue to attending and to working very hard, and start working on your group assignment now. I'll finalize your groups now, but thank you very much. I really appreciate all your efforts.